Hi there, Team MAI here again. In this video we would like to show you how we use the camera to calculate our position inside the arena. To start out, we will need to declare these variables, some of which we will use in this video and some of which are just for the future. First up, we'll have to take a look at a regular robot picture. Now let's reduce that down to what's really important here, and let's reduce that down even further to the individual markers. This is basically what the robot can see whenever you take a picture. So let's put this aside for now, and first up we will have to sort the markers in the picture by their type. We use this method to do so. What it does is it goes through every marker in an array given to it and sorts it into one of three arrays: arena markers, token markers, and robot markers. In the end it just returns the three arrays, and that's pretty much it. So let's run it. Alright, now that the markers are sorted by their type, we have to sort them by their distance to the robot. To do that, we use this method. First up, it creates an array where the sorted markers will go. After a quick check, if the array given in the parameter is null, one marker is taken from the parameter array and put into the sorted markers array. Now we go through every marker in the unsorted parameter array and insert it into the sorted markers array as soon as its distance is smaller. If it's longer than all the already sorted markers, it gets appended at the end. Basically, it's just an insertion sort. In the end, the method returns the sorted markers array. Now let's test it out. Okay, now that all markers are sorted by their type and distance, we can finally move on to the main part, calculating the position inside the arena. First up, we will need an arena, and then we will need a coordinate system. We chose ours to have its center be at the center of the arena, because this makes further calculations a lot easier. For this method, the parameter only needs to be one arena marker. Using the distance to the marker and the angle, we can use simple trigonometry to calculate the relative distance to the marker. We have to switch between sine and cosine and plus and minus sometimes, because the countercathete and anticathete sometimes represent x, y, or minus y. Now we just need to add the position of the marker inside the arena to our relative position to the marker to get the arena position. The relative positions of the markers are stored in two arrays, one for x and one for y. Let's run it. Alright, now we know the position of our robot inside the arena. In this case it's 1, 1. But now we still need to find out our robot's angle inside the arena. Luckily, we have a method for that as well. Just like the last method, it only takes one arena marker as an input. This can be the same marker as before. It calculates the relative angle to the marker using orientate.y and center.y, and then adds on either 90, 0, 270, or 180 degrees depending on what wall it is looking at. Before saving the angle to the global variables arena angle and estimate arena angle, it quickly makes sure that the angle is between 0 and 360 degrees. Let's quickly run this one too. After all of that, we finally know our position and angle inside the arena. We can use that to move around and capture tokens more easily. Anyways, that's it for this video. Good luck and happy coding!